explaining the Mewtwo package, which provides a segmentation analysis for any given dataset. Before starting, just to let you know that we have published all the documentation into PyPy and GitHub, so feel free to download it and implement it into your own datasets. Let's first review what we will be discussing on this video. First, we'll go through the segmentation analysis concept together with a brief explanation of the dataset that we will be using in this video to explain the package, although as we said before, the library can be used for any given dataset. Then, my colleague Ahmed will be explaining the missing not at random method that is included in this package and that identifies potential segments of the population based on sharing missing not at random values. Later on, Isabel will drive us through a data cleaning and data preparation process that we have applied in this dataset, and finally we'll go through the variable by variable risk segmentation analysis. So what is segmentation analysis? Segmentation analysis is understood as any kind of non-guided technical procedure designed to reveal a set of non-apparent, natural, and meaningful groups based on a multivariate input. Unlike traditional unsupervised customer segmentation techniques that are qualitative in nature, a risk-based segmentation model uses a quantitative approach to identify various customer segmentation criteria based on an outcome.
Throughout the video, we will be working with the auto loans data dataset, which contains historical data of consumer behavior for car loans customers, including information such as the opening and closing dates of the loan, the original booked amount and the outstanding amount, the car type, and the loan program. Additionally, for each of the customers included within the dataset, we are also provided with a set of demographic variables such as the gender, the birth date, and the profession. In this case, our target variable will be the bucket variable, which provides information about the number of unpaid installments at each reporting date. The aim of this segmentation analysis is first, to identify different potential segments sharing data. This is based on the pattern of missing not at random values. And second, to identify different segments of customers with different levels of risk, which we call the variable by variable risk segmentation analysis, which we will explain in detail later in this video. However, note that the segmentation analysis has been thoughtfully designed to be applied to any given dataset, so you will be able to carry out the segmentation analysis on your own datasets.
Thanks, Isabel, for this nice introduction. So I'll take you through the missing not at random method in our class. The first thing, this method basically is taking a data frame as an input. And the first thing we do is to check if there are any user errors. So if the user gives us more arguments than needed, or if the user gives us something that is not a data frame at all. Then we get a list of what we call them null columns. So any column that will have a null value, we will include the column name in that list. Second, we loop through those null columns and we create for each of them a respective temporary underscore test column. This column will have 0 in case the original column is null value, or 1 in case it has a value. The purpose of this is basically to calculate the number of nulls versus nulls. Okay. Then we go through a three-way nested loop, as you can see. The purpose of this nested loop is basically to populate the NR columns list. The NR columns contains the list of missing not at random columns, and that is very important to know because we need to understand the behavior of the missingness of the data in our data frame. So how do we do that? It's easy. We take the sum of not missing values for a certain category, and then we calculate all occurrences of that category, and finally we form a condition of ratio, let's say, between the not missing and all the values, and if it is no more than 90%, then we know that it is a missing not at random. And then we also, to give the user the best recommendation, we populate related column and related categories, and that will have where the missing not at random occurs with which categories, with which columns for which categories. And then finally we print this nice report after dropping the temporary columns. And to see the report in action, here is the report in our Jupyter notebook. We give what variables are missing, not at random, and then both the thin and full file segments, which are basically the full one is all the columns except these, and the thin is all the columns except these. Sorry, it's the other way around. The thin will have all the columns except these, and the full will have all the columns including these. And finally, we give this nice correlation recommendation that those variables, basically each one where the missingness not at random occurs, for the user to take further action. So thanks for listening, and my colleague Paula will take you through the rest of it.
Our segmentation analysis requires some basic data cleaning and data preparation. Now, we will quickly go through the data cleaning and data preparation process that we have performed on our dataset. We will divide this into two parts: basic transformations and feature engineering. As we can see on the screen, we performed some initial steps to make our dataset more manageable. First, we modified the names of the columns to lowercase. This is to ease the next steps of the coding. The second step was to remove duplicated records. We removed duplicated records based on the variables account number and customer ID. The aim of doing this is to keep the last record of each account customer may have. Finally, we binned our target variable bucket, which originally provided information about the number of unpaid installments at each reporting date. By binning this variable, we'll identify those customers without unpaid installments. They will be reported as 0, and those with 1 or more months in default will be classified as 1. Now we will do the second part, which is feature engineering. We will start with the date variables. To get more information from these variables, we decided to calculate the time difference between some of the related date variables and also the date of the report. We performed two main transformations. First, we calculated the expected loan duration in terms of months. For example, 44 months or 60 months of loan. And for the birth date, we computed the age based on the birth date and the date of the report. Apart from these two main date transformations, we have also performed several other date transformations, as you can see on the screen. Now that we have dealt with the date variables, we also decided to transform the sex variable into a binary variable. And then we removed non-relevant columns such as account number and customer ID. We've already used these variables when we analyzed duplicated records. The last step within the data preparation and cleaning process before running the variable by variable risk segmentation analysis that we will see in a minute is to transform categorical variables. For the segmentation process of categorical variables, dummy transformation is not practical since the results obtained in the decision tree will not be reliable. Therefore, we have pre-transformed categorical variables into numerical variables using the observation rate. This is the probability of each category belonging to class 1 of our target variable, meaning the customers with 1 or more months in default. In our case, we have 3 categorical variables, which are program name, profession, and car type. And now that we've done the observation rate, you can see that we have program name rate, profession rate, and car type rate. Before we deal with the missing values in our dataset, we will first perform a missing not at random analysis using our risk data frame class.
Now we'll go through the variable by variable risk segmentation analysis, which aim is to identify segments of customers with different levels of risk. Once our data is clean, we can proceed to run the find segment split method, which will return a list of the variables that we should use to split the dataset, together with the threshold on where to split the data. Just a quick remark before explaining the method. The dataset must be clean and data types must be informed before running the data frame. However, we have applied a set of functions throughout the method with the aim of checking for possible errors when importing the data frame. Let's see some examples on the screen. Now, let us go through the find segment split method to understand the logic that we have applied. After checking for possible errors, we have applied stratified random sampling to reduce the dataset sizes and speed up the segmentation process. This sample has additionally been split between the train and test data frames. The segmentation process is carried out using a decision tree classifier which identifies which variables are relevant for segmentation analysis, providing the threshold where the dataset should be split. By running the decision tree and storing this information with the getRules function, we can apply the records function, which will return the user the rules of the decision tree, that is the list of the relevant variables for the segmentation and the threshold for each variable. For each of the variables that has been identified as relevant for segmentation analysis, we proceed to calculate the Gini coefficient for the full model and segmented model. How is this performed? We simply divide the train and test data frames into segment 1 and segment 2 based on the threshold provided by the decision tree. For example, if the age variable is considered relevant for the segmentation with a threshold of 45 years, we will divide each of the test and train data frames between customers younger than 45 and those older than 45. As we'll see now, the outcome of the find segment split method will be a printout of the variables of our dataset, indicating for each one of them whether it should be considered or not for segmentation, and if so, the threshold of the split. Finally, this package contains what is called the final report method, which will provide a user with a printout of both the methods that have been previously defined. So, let us print the final report for our dataset. As we can see, this report will give us the printouts for both the missing method random report and the variable by variable resegmentation analysis. Thank you very much for watching this video. We hope this package is useful and you are able to apply it to your own datasets.